In this program, you'll learn to recognize the sound of a leak. We'll demonstrate the basics of locating a leak. We'll also discuss some tips for detecting leaks in a noisy environment. We'll demonstrate the use of the warble tone generator. And finally, we'll demonstrate the liquid leak amplification method. First, let's talk about recognizing the sound of a leak. A leak produces a turbulent flow as escaping gas moves from the high-pressure side of a leak to the low-pressure side. This turbulent flow is heard as a distinct rushing sound. The sound of a pressure leak is similar to that of a vacuum leak, but they do possess detectably different sound qualities. Listen carefully for that difference as each is demonstrated. This is the sound of a pressure leak as it will be heard through your ultraprobe. This is how a vacuum leak will sound through your ultraprobe. The difference is like the subtle difference between the sound of inhaling and exhaling. Once you can recognize the sound quality of leaks in your environment, you can learn to locate a leak. Now we'll take a closer look at the leak detection procedure. First, using the ultraprobe scanning module, we will follow the intensity of the signal to get closer to the leak site. This is the first step in what we call the gross to fine method. To pick up gross signals, scan with the sensitivity level set for most situations at maximum and use the fixed band mode. The meter mode should be in the log position. Scan the area, closing in on the leak site by listening for its characteristic rushing sound. Next, use the rubber probe to narrow the field as you get closer to the leak site. Then reduce the sensitivity to pick up the fine ultrasonic signals and listen. Follow the ultraprobe by watching the meter and listen for the loudest point. Once the leak has been located, confirm the site by moving the probe back and forth in all directions. In certain situations, a stray signal may be heard. To make sure you're hearing a real leak and not a stray signal, place the rubber probe directly over the leak site. A stray signal will drop off. The sound of a real leak will persist. These 5 steps are all you'll need to find most leaks. Now let's discuss some techniques for detecting leaks in a noisy environment. When possible, it is best to turn off the source of competing ultrasound. However, it is often difficult or impractical to turn off competing sounds. In these situations, various shielding techniques can be used effectively to block out competing signals. First, try the rubber probe to deflect the unwanted sound. Changing the angle of the ultraprobe may also help. You can use your body to block out competing sounds. An object, such as a clipboard, may produce the same effect. Or you can cup your hand as a shield. The wipe rag technique can be another simple and effective way to block out competing ultrasounds. Draping a welder's curtain or drop cloth is yet another possible solution. You can also try one of the UltraProbe's advanced features, the tunable frequency filter. Change the frequency tuning on the UltraProbe to about 40 kilohertz. In order to adjust it to the exact frequency, use this simple method. Sniff while adjusting the frequency until the clearest sound is heard, and continue to scan as previously demonstrated. These techniques can be applied to all types of leak detection problems. Most of the standard techniques apply even to detecting electrical leakage, both arcing and corona. Electrical leaks make a frying or buzzing sound. When scanning high voltage lines or transformers, be sure to follow your standard safety procedures. Now let's discuss use of the warble tone generator. The tone generation method can be effective in situations when it may be difficult to pressurize or create a vacuum. The tone generator is placed inside the item being tested. Ultrasound is then transmitted, filling up to 4,000 cubic feet of space. Because ultrasound is a shortwave signal, it deflects off solid surfaces, but will penetrate any pinhole leak. The same scanning method described earlier, used on the other side of the test surface, will pick up any escaping ultrasound indicating a leak site. Listen to the ultrasound penetrating this seal. When placing the warble tone generator, the following factors should be considered. First, the detectability of the leak will be affected by the thickness of the wall, how close you can be to the leak, and the size of the leak. To detect a small leak in a thick wall, you must be closer than to hear a large leak in a thin wall. Second, if there are a number of bends in the test surfaces, the ultrasonic signal will dissipate, dying out completely after 3 or 4 bends. If this occurs, use more sound to compensate. If using more sound doesn't work, you may need to revert to the pressurization method. Next, remember that any solid or liquid can block ultrasound. If there is any liquid that could inhibit the detectability of ultrasound in the test area, it should be cleared. You can clear it by simply blowing it out with air. And finally, it is important to know that the ultrasound signal does not pass through more than one medium effectively. Therefore, when testing an area with multiple surfaces, you may need to place the warble tone generator between the layers, such as between 2 walls. The warble tone generator can be an effective tool in difficult situations. Another important technique which can enhance the detectability of a leak is the liquid leak amplification method. When at or near the threshold level of the instrumentation, the intensity of the signal is important. The detectability of a leak in this case is affected by factors in your environment, such as fluid viscosity, the orifice configuration, the distance from the leak to the orifice, atmospheric conditions, and pressure differentials. The liquid leak amplifier is a low surface tension liquid. Poured over a suspected leak site in small amounts, it forms bubbles. These bubbles collapse, creating ultrasound which is distinctive and recognizable. If you've used a bubble test before, you'll appreciate the difference hearing, not just seeing, can make, especially when there are several leak sites or inaccessible areas to be checked. When using liquid leak amplification in a low-level vacuum system, use the contact module rather than the scanning module. When the liquid is sucked through the leak site, it will form bubbles that collapse, creating ultrasound detectable with the contact probe. If your vacuum system cannot tolerate liquid leak amplifier, use a liquid it can tolerate, such as alcohol or distilled water. The liquid leak amplification method can be an effective way to enhance the detectability of a leak.